Math 1000 test, practice test for Chapter 8. We are doing quadratic functions, and the first step is to solve these quadratic functions, and you're going to use whatever method you need to solve them. So the first two you may factor. They are simply factorable on this practice test. Now, if they're not factorable, you're going to want to use whatever method you want to use to solve them. So, for example, for this one, it is factorable. So once you've determined whether or not it is factorable, and on your practice test I'm telling you that these two are, you're going to use your knowledge of factoring. And for this one, since it is factorable, 3x times x is 3x squared. Now, this is the one that's the more difficult one where you're going to have to guess and check. So you may want to guess and say, okay, what two numbers multiply to give you 20? So I'm going to guess 5 times 4 gives me 20. Now, because I need a 19 here, I'm obviously going to, positive 19, I'm going to put 2 plus signs here. Now, I'm going to FOIL, and when I do my foiling, my first, outer, inner, and last have to multiply and add. My outer and my inners have to add to be 19. So this gives me 12x, and this gives me 5x. Okay, now that does not give me 19x. So what I want to probably do is switch these two around. So let's put, this is the one that confuses people. So let's put a 4 here and a 5 here. So now when I do my 3x times 5x, I get 15x, and 4 times x is 4x. Now when I add these up, I get my 19x. So this combination does now work. So this is my combination. Now what I'm going to do is now I'm going to set each of these equal to 0. So 3x plus 4 equals 0, and x plus 5 equals 0. So I'm looking for what x has to be to set it equal to 0. So now finishing this off, I'm going to subtract 4 and divide by 3. And then subtract 5. So my two possible answers are negative 4/3 and negative 5. And you could plug these numbers in and check, and they both work. Now for number 2 is an easy one to factor. Always make sure your trinomial or polynomial is set equal to 0, which it is. So, what two numbers multiply to give you 5 but add to be 6? That's easy. 5 times 1, positive 5 times positive 1 is 5. 5 plus 1 is 6. So setting each of these products equal to 0. So 5, this would be a negative 5, and this would be a negative 1. Okay, next one. Again, we have a quadratic function. We are solving for x squared. I'm noticing that there's no middle term. So I'm going to get this x squared isolated. So I'm going to first get rid of this 2. I'm going to add 2. This becomes 49. Again, I want to isolate x squared, so I'm going to divide by 25. So x squared is equal to 49 over 25. So I'm going to write it over here. X squared is equal to 49 over 25. Now, I don't want x squared, I want an x. So I'm going to take the square root of both sides. And my answer is plus or minus 7/5. Don't forget both answers. Next one. Number 4, I'm going to take the square root right off the bat of both sides. X minus 8 equals plus or minus 12. Add 8. 8 plus 12. And 8 minus 12. So my two answers are 20 and -4. Next one, number 5. I'm going to bring 8 to the other side. That becomes a positive 8 on the other side. I'm going to square root both sides. Now don't forget to simplify this. You just learned this in chapter 7. This is going to be plus or minus 2 root 2. And swing 3 over to the other side. This 3 becomes a -3 plus or minus 2 root 2. Those are your two answers. These are called exact answers. Estimated answers are when you take them out of the radical. We don't need those answers for these. You're going to want the estimated answers when you go to graph these. Number 6, you're going to take the square root of both sides, and I want you to use your knowledge of imaginary numbers. So you get x minus 8 equals plus or minus 5i, and then bring -8 over. Now these are not like terms. Those are your two answers though. Leave it alone. Okay, for number 7. Number 7 is a quadratic equation, and one of the methods that you're going to use is completing the square. Now this is not factorable. I don't know what two numbers multiply to give you 2 that add to be -8. It's not factorable. And it has a middle term, so I can't take the square root of both sides. So I'm forced to either complete the square or use the quadratic formula. I'm going to use completing the square on this one. So the steps to completing the square are, first of all, you want to make sure there's a 1 here. There is. I'm going to bring 2 to the other side. This 2 becomes a -2. You take half of this, which is -4, and you square that number. Half of that squared is 16. That number gets added to both sides to keep it balanced. Whatever you do to one side, the same thing has to be done across to the other side. When you factor this left side, that number that you cut this in half, that's the number that you get factored. It's twin binomials, x minus 4 squared. -2 plus 16 is 14. Now this looks like take the square root of both sides problem. You get x minus 4 equals plus or minus root 14. Now if this was simplifiable, it's not. You should simplify it. Like for example, if that were a 12, you could take a 2 out, but 14 is 2 times 7, so there's nothing common to pull out, but if there was, you're responsible for being able to do that. And now you're going to bring -4 over, which becomes a positive 4. This is a exact answer. That's your answer. Next one. Now, this one, in order to use completing the square, we have a problem at 3. So we want to divide everything by 3, all the way across. You get x squared minus 4x plus 2 equals 0. Now we're going to swing 2 over. Half of that squared. Factor. Square root. And bring 2 over. Make sure you switch that sign. Next page. The quadratic formula is good when the problem is not factorable, and it's especially good when the middle term is an odd number. This one I would not try to divide by 5. I would be forced to use the quadratic formula on this one. So, the problem with this one, before we use the quadratic formula, we want to organize it to make sure we know what A, B, and C are. So I want to bring -6 over, it becomes a +6. This is your A value. A is 5. B is -12, and C is 6. So let's write that down. A is 5, B is -12, and C is 6. So you're responsible for knowing the quadratic formula. It is the opposite of B, plus or minus the square root, B squared minus 4AC all over 2A. It always helps me to write that formula out. So the opposite of 12 is going to be a +12. 12 squared is 144. This number is always a positive number. Minus 4 times A, which is 5, times C, which is 6, all over 2 times A, which is 10. Okay, so 12 plus or minus, this is 20. 20 times 6 is 120, so we have one. Show all your work. So if you have a math error, partial credit can be given. That would be 24. And we're going to pull out a 24. If you break 24 up, 2 times 2 is, and then 8. So that would be 2 root 6. So it's 12 plus or minus 2 root 6 over 10. And now for this, you can simplify all of these by 2. If you take a 2 out of 12, you get 6. 2 out of this. Do not take the 2 out of that. And then a 2 out of this. And that's your simplified answer. And for this one, you could use completing the square if you wanted to, or if you want to use the quadratic formula, you can. Either one, quadratic formula, the opposite of B. So B right now is -8. A is 1, and C is 19. So let's write the formula. So we have 8, because it's the opposite of -8, +8, plus or minus, this would be 64, minus 4 times 1 times 19, all over 2 times 1. Now for this one, I'm noticing that when you multiply this, something's going to happen. Let's see, 8 plus or minus 64, I don't have a calculator, but 19 times 4, 36, 76. So what's going to happen here is we're going to have a negative underneath the radical. So we have 76 minus 64, which is 12. So this is going to be 8 plus or minus negative 12 over 2. This is a negative 12. So we have an I in here. So it's 8 plus or minus 2I root 3 over 2. We can simplify all of this by 2. So we have 4 plus or minus I root 3. 2 goes into 8 4 times. 2 goes into 2 once. Next one, the discriminant. And by the way, going back to this one, in offshoot on this one, the discriminant for this problem is negative 12. That means that there's no real solutions. Here's another discriminant problem. In order to figure out what the discriminant is, this has to be in order. Okay, so your A value is 4, B is negative 8, and C is negative 10. The discriminant is B squared minus 4AC. So again, you're going to take negative 8 and square it. Minus 4 times your A value, which is 4, times negative 10. So we have, make sure when you're doing this in your calculator, use your parenthesis button. Negative 8 squared is not negative 64. If you get negative 64 in your calculator, you're not using your calculator correctly. This should come out to be positive 64. Now, this, you have a negative 4 times negative 10. This is going to come out to be a positive. 4 times 4 is 16, and 16 times 10 is 160. So 160 plus 64, so you should get 224. So your discriminant is 224. Do not take the square root of it. Since that's a positive number, that means there's 2 solutions. If your discriminant is positive, that means there's 2 solutions. If the discriminant comes out to be 0, that means there's 1 solution. If it comes out to be negative, there are no real solutions. Number 12. These are not quadratic. This is in quadratic form. There are up to 4 real and imaginary solutions. There's 4. So what you're going to do, you're going to factor this as you would a quadratic. Okay, first make sure it's set equal to 0, which it is. Now, how would you break up, if it were x squared, you would write x times x. But since it's x to the 4th, you're going to split this up, x squared, x squared. What 2 numbers multiply to give you 8, but add to be negative 6? Just like that. Now what you're going to do is set each of these equal to 0. So x squared minus 4 and x squared minus 2. So solve each of these like you did in 8-1. Add 4. And then square root both sides. So when you square root this side, x is equal to plus or minus 2. Don't forget plus or minus. This one, add 2. And you get plus or minus square root of 2. So there's 4 answers. Plus or minus regular 2 and plus or minus square root of 2. Number 13. For number 13, you should see this one. You should see x plus 2, the quantity squared, plus 7 times x plus 2, plus 12. You're going to remove this x plus 2 for a second. Pretend like this says a squared plus 7a plus 12. So in other words, you're going to let, for a minute, let a equal x plus 2. So we're going to replace this x plus 2 for just an a. So we're going to write a squared plus 7a, and we're going to solve this for a, because this is easy to do that. So we have a, 4 times 3 is 12, but adds to be 7. So if we solved for a would be -4 and -3. But we're not solving for a, we're solving for the letter x. So now we're going to switch. Our a value was x plus 2. So now we're going to replace, switch back. We're going to remove, we're going to instead put the a value for x plus 2. So right here, because a is really x plus 2. So a is not -4, x plus 2 is really -4. A is not -3, x plus 2 is really -3. So what would x really be? Now we're going to subtract 2. So x is really -6, and x is really -5 based on subtracting 2, subtracting 2. So x is -6 and -5. And this one is based on the radical problems. How would you break up 2/3? Well, 1/3 times 1/3 is 2/3. What two numbers multiply to give you -10 but add to be 3? That would be 5 times -2. So set each of these equal to 0. And x to the 1/3 minus 2 equals 0. Subtract 5. So you're going to cube both sides. So x is equal to, what's -5 times -5 times -5? That would be -125. This side, you're going to add 2. And you're going to cube both sides. So 2 to the 3rd power would be 8. So your two answers are -125 and +8. Okay. In class, I showed you how to find the vertex by this formula. X is equal to, this is the axis of symmetry, (b over 2a). So the b value is -6 here. So it's the opposite of that. So that would be 6 over 2. The a value is 1. So 6 over 2, which is 3. So then you're going to plug 3 for x. So the y value is 3 squared minus 6 times 3 plus 4, which gives you 9 minus 18 plus 4. That's -9 plus 4 is -5. So your vertex is 3, -5. Number 16, write an equation of the parabola. This one, here is your form. Y equals a times x minus h quantity squared plus k. This vertex, this is your h, the 3 is your h value, your k is your 2. So it goes hk, that's your vertex, hk. And this passes through, this is your x and your y value. So the only thing not given to you is your a value. That's your unknown. So all you need to do is plug in. If y is -6, a is our unknown, x is 5. 5 minus h is 3. And k is 2. We're looking for a. So, order of operations, 5 minus 3 is 2. 2 squared is 4, so you have right here, you have 4a. Solving this equation for a, we're going to subtract 2. 4a equals -8. A equals -2. So, here's your a value, -2. So your equation would be y equals -2 times. All you need is your vertex, your hk. So it'd be x minus 3 quantity squared plus 2. H and k are necessary. The a value needed to be found and your y and k to write an equation. Now, of course, you could, if you wanted to, you could FOIL this out, multiply the -2, but it's not necessary. You can leave it in this form. This is called vertex form. Number 17. Now we're going to graph these. So, step 1. How do you know if your parabola is up or down? You look at your a value. If your a value, which this is a 2, if it's positive, it's up. So this is an up. It's going to be shaped like that. Now your vertex and axis of symmetry. To find your vertex, you first want to find your axis of symmetry. Your axis of symmetry is found by x is equal to -b over 2a. Well, b is -8, so it'd be +8 over 2 times 2. So 8 over 4, which is 2. So your axis of symmetry is x equals 2. X equals 2 is this line right here. Now, you have to plug in 2 into this equation to find y. So y would be equal to 2 times x is 2. So 2 squared minus 8 times 2 plus 12. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16 plus 12. Well, 8 and 12 is 20. And 20 minus 16 is 4. So your vertex is 2, 4. So 2, 1, 2, 3, that's your vertex. Now, because this thing is going up, this is telling me that there is going to be no x-intercepts. And also, this special number right here is called my y-intercept. So my y-intercept is 0, 12. My vertex is, I should write that here, 2, 4. Fill in my blanks. So let's put in my y-intercept. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. They're right at the top, right there. Now, because of my axis of symmetry, I'm going to go 2 across because I want to make my graph look nice and symmetrical. 2 across from my axis of symmetry, 2 across this way. Now, I'm going to draw my graph the best I could. making it symmetrical and curvy. And I know, based on the fact that my A value is a positive, that's my vertex, my y-intercept is 12, this thing is not going to cross the x-axis. So, what are my x-intercepts? There are none. Now, I could prove it, and I could try to factor it, I could do the quadratic formula. What I'm going to find out is my discriminant is going to be a negative number. There are no x-intercepts. So make sure you fill in all your blanks. Your x-intercepts, there are none for this one. Next one. Same process. We're going to graph this one. My axis, this one's down because my A value. So my vertex is going to be my maximum point. Starting off with my axis of symmetry, my B value is 2, so I have negative 2 over 2 times negative 1. So I have negative 2 over negative 2, which x is equal to 1. Now I'm going to plug 1 in here. So my y value is negative 1. Be careful with these negatives here. Negative 1 times 1 squared plus 2 times 1 plus 3. So 1 squared is 1. 1 times negative 1 is negative 1 plus 2 plus 3. So 5 minus 1 is 4. So my vertex is 1, 4. 1, 4. 1, 4 is my vertex. My axis of symmetry goes through my vertex. My y-intercept is 3, which means I have that point that's symmetrical. So 0, 3 is my y-intercept, which means this thing is going to hit the x-axis somewhere. How do I find that? I have to plug 0 in for y. So this is where the fun begins. I'm going to plug 0 in for y. And now I have to use one of my methods. Am I going to try to factor this? Well, let's see. I'm going to first get rid of my negative here. I'm going to divide everything by negative 1. Is this factorable? Well, it kind of looks like it is. Does that factor correctly? Sure does. So negative 1, the opposites of these are my x-intercepts. Negative 1, 0, and 3, 0. Here's my graph. Number 19. This one's in vertex form. This little piece right here, the opposite of this, x equals 2, is your axis of symmetry. And the opposite of this, comma this, is your vertex. So 2, 4 is your vertex. And this is going down because your A value is negative 1. So we have our vertex, 2, 4. Now, axis of symmetry is x equals 2. Now to find your x and your y-intercepts, you have to plug 0 in for x or y into this equation. So if you're looking to find where the graph hits the y-axis, you're going to plug 0 in for x. So you're going to take y, solve for y. So you have negative 1 times 0. You're just doing the math here. I'm setting x equal to 0. That's all I'm doing. Because your y-intercept x is 0. So following the order of operations, 0 minus 2 is negative 2. Negative 2 squared is 4. 4 times negative 1 is negative 4, and negative 4 plus 4 is 0. So 0, 0 is your y-intercept, which means you're going to have a symmetrical point right there, which means that's your x-intercept. So I bet you if we set this equal to 0, so if we did this, and solve now for x, watch what happens. We're going to subtract 4. Subtract 4, you get negative 4, then divide by negative 1, get rid of this, divide by negative 1, you get this now becomes a positive 4, square root both sides like you did in A1, subtract 2, negative 2 plus 2, and negative 2 minus 2. That's where you get your 0 and your negative 4 for this. That's where these two lined up right there. 0 and negative 4. So 0, negative, 0, 0, negative 2 plus 2 is 0, and negative 2 minus 2 is negative 4. Oh, because this is a minus 2. I'm sorry, my mistake. Somehow I lost a negative. These are minuses, that's why. So I should have added 2. So it should have been 4 right there and 0. 4, 0, and 4. 0 and 4. This is a minus 2. And your y-intercept is 0, 0. I want to add one more review question on here. And that would be if you had to graph something like y equals x squared minus 7, or y equals x squared plus 3, something like that, or y equals x squared minus 4. And all that this is a parabola that the parent function, y equals x squared, is on the origin, and it shifted 7 units down, 3 units up, or 4 units down. So for these, your axis of symmetry is your x equals 0. So if you had to do any of these, all you have to understand is that, like for this one, you're shifted 4 units down. So this one, you're shifted 4 units down, 1, 2, 3, 4. 4 units down. So your vertex is 0, negative 4. If you were to set this equal to 0, and factor this, x minus 2, x plus 2, your two x-intercepts are 2 and negative 2. So it'll look like this. Now for something like this, x squared minus 7, how do you know where your graph is going to hit the x-axis? because you're going to be shifted 7 units down. When you set this equal to 0, when you set this equal to 0 and you bring your 7 over, you're going to have x squared equals 7. When you take the square root of that, x equals plus or minus the square root of 7. This is the only time when you're going to need a calculator to take the square root of 7 to find out what it's between. So your x-intercepts are the square root of 7. So make sure you understand how to do those problems as well. Number 20, these are the inequality ones. And I'm only going to have you graph the solution. So what you have to do is factor this. How do you factor x squared minus 8x plus 12? Well, you should know how to factor that. It's going to be x times x. What two numbers multiply to give you 12 but add to be negative 8? Be 6 and 2. So your critical values are 6 and 2. So what I want you to do, you're going to draw a number line, and you're going to graph 2 and 6. So what you're going to do is you're going to pick a number to the left of 6. Like, for example, what number is to the left of 2? 0. If you picked a number like 0, and you put 0 right here, 0 minus 6 is a negative number. And if you put 0 here, 0 minus 2 is a negative number. A negative times a negative is a positive. And a positive number is not less than 0. So this interval is not any good right here. Now if you put a number in between this interval, like 3, let's test the number 3. 3 minus 6 is a negative number. 3 minus 2 is a positive number. A positive times a negative is a negative, and a negative is less than 0. So this region will work, right in between here. Now if you picked a number out this region, like 8, 8 minus 6, positive, positive. A positive times a positive is bigger than 0. This region would not work. Now, because these two numbers are not, you don't have an equal to sign, we will use open circles. If there was a bar here, we would color them in. Now, you may also, instead of using open circles, you should know in this class, open circles are the same as parentheses. So the solution is 2 to 6. So if you wanted to write it in interval notation, it is 2 to 6. That is the solution. This is the graph, 2 to 6. If there was a bar here, these would be colored in. These would be brackets. These would be brackets. And these would be brackets. Just like that. Okay. Now for a rational inequality, you do the same thing. You have to find your critical numbers. So what would generate a 0 here? Let's make a number line. We've got a negative 4 and a positive 3. So we want less than or equal to 0, so negative. Less than 0, negative. We're looking for where you get a negative. So let's test to the left of negative 4, like negative 5, negative 6, negative 7. So if we put a negative 10, if we put a negative 10 here, you're going to get a negative number divided by another negative number. A A negative over a negative is a positive. And a positive number is not less than 0. False. How about if we test a number here, like 0? We put a 0 here, we'd get a positive over a negative. Positive over a negative is less than 0. So this region does work in the middle. If we tested a number greater than 3, like 4, we'd get a positive over a positive. Positive over positive is not less than 0. This region does not work. Now, the problem with these two numbers, although there's an equal to sign, our first instinct is to want to color these two in. The problem with coloring them in is this is a fraction, and it's a big no-no to have it colored in. You don't want a 0 here. So this has to be open circle. For a fraction, you never want that to be colored in, that bottom. Even though that's an equal to sign, you never want a 0 in the bottom. So this would be an open circle, even regardless of the fact that that has an equal to sign. So now, you should be able to write this in either way. So -4, 3, that would be one way to write it. And you could write it in interval notation. That's one way. Either way is fine. And that's the end.